So I want to use the opportunity to work through a little bit of the math. So I've prepared a problem for you, which I'll put up on the overhead here in just a second, and we'll capture on the video. And then ideally, take a few minutes to try it. You know, pause the video, muddle through it for a few minutes, or solve it. That would be great. And then unpause the video, and we'll kind of work through the solution for it. So we want to be able to effectively solve out these values. You know, we want to kind of see the impact on y. Solve for y1. We know the impact of changing y. We can solve a change for it. So if we can find a starting y, we should be able to determine these effects. Now the textbook walks us through, I should have talked about this a second ago with the multiplier, sorry. Walks us through another type of multiplier with taxation. It's actually just an extra step you don't need. You should be able to solve any taxation change using the two formulas we have. So given that in mind, I kind of go past that, because why make three formulas when the two we have work perfectly? So one thing to remember is if we're solving out y, we know that y is equal to c plus I plus g plus nx. And remember, we had solved out this c, so we could rewrite this as y is equal to effectively a plus mpc di plus I plus g plus nx. So I've kind of come up with a couple of practice ones here for you to try. I want you to solve for y, given the information that I provided. So hopefully the camera catches all of this. We're going to turn the lights out, and I'm going to come over to our projector, and I'm going to put up our problem. I made two of them, so this chair might be in the way. Move that out of the way. So we've got problem one up here. I've given you the values. Problem two, I've made a slight change in it. So is it good? All captured? Mm-hmm. Okay, so if you would like to go ahead and pause the video right now, pause it and work through this, and then come back in a few moments, and we will work on this together. Okay. So hopefully you had the opportunity to work on this a little bit here. I'm going to go back over to where I was on the board, and so I can look at it there. And let me get my information on the values, so I have the values, because I need to put the lights back on and so forth. So we wanted to solve for y in that question, right? So if we look at number one, I gave us values for autonomous consumption. I gave us a value for I, for g, for nx effectively. So I want to go ahead and put these in right now. So I'm going to say that y is equal to, again, you know, we'll kind of bracket this out, 1.0 plus, I gave a value of MPC was 0.85 times DI plus 2.9 plus 2.5 minus 1.0. So those are my values that I had. So first of all, I guess I'll bracket that. First of all, since this is all addition, one thing that I can do right away is that I actually could just cancel out my ones, but I'm not going to do that just yet. I'm going to leave my consumption function as is, and I'm going to go ahead and reduce this out. So I would get 4.4. So I could kind of rewrite this as 1.0 plus 0.85 DI plus 4.4. Now, in the question, it gave me a value for taxes and transfers, and it said they were both 0, right? So if I know that my equation for disposable income, just putting it up here as a reminder, was y minus taxes plus transfers, I end up having a disposable income of y minus 0 plus 0, or in this problem, I have y equal to di. I'm going to take that information and plug it in right here. So I would now be able to rewrite this whole equation as 1.0 plus 0.85, in this case y is equal to di, so 0.85y plus 4.4. Let's go ahead and get these numbers together, right? 1 and 4.4, which means I can rewrite this now as y is equal to 0.85y plus 5.4. So one of the most common math mistakes I see here is just because we are all totally in love with trying to divide things out. People will say, oh, I can divide everything here by 0.85. Actually, you can. It's not the right step, and it's going to add a lot of extra work. This is just an addition problem, so don't do that. All you have to do is subtract 0.85y from each side. So if I subtract 0.85y from each side, I'm left with 0.15y equals 5.4. Divide by 0.15, and I get y is equal to 36. So on number 1, you should have gotten a solved value of y equals 36. Number 2 said keep all the values the same, except we're going to have taxes and transfers now. It made taxes 3.5 and transfers 5, which means I need to rewrite my consumption. So in number 2, the consumption component was equal to 1.0 plus 0.85 times di. Well, 1.0 plus 0.85 times, use our formula up here, y minus 3.5 plus transfers 5. So y minus t plus tr. And I can actually kind of, I can simplify this a little bit and work this through, right? I can add these two together here. That gives me a value of positive 1.275. Yeah. No, hold on, I skipped a step. That gives me a value of positive 1.5. Okay, so I can now distribute this through 0.85 times y and 0.85 times 1.5. Sorry, I skipped that step there. And then I would have a value of c is equal to 1.0 plus 0.85y plus, where'd it go? 1.25. At this point, I can now solve out the problem exactly as I did here. So if you haven't done that, go ahead and give that. Go ahead and give it a shot. Pause the video now and see what you get. Okay, so hopefully now that you've kind of seen the trick to this one, you've been able to kind of go through and finish out the solve. So I'm going to take this value and plug it in for my c term right here. So my 4 plus 4.4 is going to stay because all of those variables stayed the same. So I'll just say plus 4.4. And then I'm going to use the exact same strategy. I'm going to combine all of the numbers and then take the set it equal to y. So I would have y is equal to 0.85 y plus whatever our combined numbers come out to. And again, kind of establish it the exact same way here. So I'll get y on one side, divide by 0.5. You should end up with a y, if you solve this correctly, you should get 44.5 for y in this one. Okay, so like I said, I know this would have taken us a little bit of time to kind of mess with in class, and I wanted to give us that opportunity. So I think that's a good spot to kind of end this class, again, assuming that in class we would have spent time doing that.